All right, nerds. So, first off, we're skipping the first part of this. That's old news. All this is technically old news, but we're going to review this bit. Okay? Again, if you already have it written down, great. If you don't have it written down, I encourage you not to. Write it down at the end. We're drawing these vectors. Notice vectors have pointy brackets, right? We have horizontal components. The 3 here is a horizontal component. The -1 is a horizontal component. 6 is a horizontal component. It tells you how much you're moving left or right. Vertical components, the second one. So 2, -2, 4, and 8 are all vertical components. Cool? So we can plot these vectors anywhere. When we did it originally, we might have done it starting at the origin. Okay? That's fine. You can do that. I'm going to plot the first one starting at the origin. 3, 2. So starting here. And it says 3 to the right and 2 up. Right? Horizontal part, vertical part. So 3 to the right, 2 up. That vector looks like that. We're supposed to call it something, so I'm going to call it vector v. Just because. Why not? You can call it whatever you want. Vector symbol is just an arrowhead, but with only half the arrow. That's the vector symbol, okay? So that's 3, 2. Now, 6, 4. Let's skip to this one. I'm going to do in red. Again, you can start a vector anywhere. It doesn't have to start at 0, 0. So I'm going to start it, I don't know, here. Just randomly. And it says 6 to the right and 4 up. So I'm going to go 6 to the right, 1, 2, 3, 4, 5, 6, and 4 up. 1, 2, 3, 4. So this vector takes this dot to here. I'm going to call it vector u. Cool? So we can move them anywhere. If you wanted the vector to be somewhere else, you just pick it up and copy and paste it somewhere else. Now, maybe you'll notice that these guys are both going in the exact same direction, meaning they're parallel. How do we know they're parallel? Well, because if you take their components, 3, 2, and 6, 4, and you put them in ratio, they're going to equal each other. So what do I mean by that? 3 over 2, they're equivalent fractions, right? 6 over 4. They equal each other, right? Which means they're going to be parallel. 3 over 2 and -1, -2. Are those equivalent? No, they're not. So those won't be parallel. They're going to go at random angles. These two are parallel because they have the same slope almost, right? They have the same vertical and horizontal components in ratio. Simplified fractions, right? So when these two equal each other, that means those are going to be parallel. And when they don't equal each other, they're not parallel. Find the magnitude. Magnitude is the size of the vector. Now notice these do not have the same size, right? One arrow is bigger than the other. So to figure out how big they are, I'm just going to do Pythag. Right? I want to know how long that is. Well, that's in an angle, so I can't just count the squares, right? But I can do this. I can count these squares. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And of course it's 6 and 4, because that's what its components are. Duh. I didn't need to count the squares. It's already written down right there. How do I do Pythag? What is Pythag? Exactly, right? A squared plus B squared equals C squared. Where A and B are the legs, right? And C is what we're looking for. So A squared, otherwise known as 6 squared. B squared, 4 squared. A squared plus B squared equals C squared. Now we want regular C, so we root it, right? Remember that? Everybody cool with that? If it was C squared, we wouldn't have the root here. If we want regular C, we have to root both sides, so that gets rid of the square here and puts the root over here. 6 times 6 is 36. 4 times 4 is 16. You can trust me on that. Add them together and then root them. That's 52. So the magnitude of vector u is root 52. This is a symbol for magnitude. That's how long it is. It's root 52. Yeah.
When we first did this, you did the range.
Right. So it says you need to do it for all of them. I just chose 2 randomly because I'm just going through this as review. Is everybody cool with that? You're going to have to find the magnitude for all of them. You're going to have to graph all of them, right? I'm just doing it for one real quick. These two are parallel. Cool. How do we feel about finding magnitude? It's p-fag, right? Feel pretty good about that? How do we feel about graphing vectors? Place a dot somewhere, do what it says. 3 to the right, 2 up. 6 to the right, 4 up. Direction matters. So you go from your starting point to the new point. How do you feel? Okay? Quiz Friday. If this was on a quiz, would you feel good about that or no? No? You weren't here the entire time while I did this. Like, the last 5 minutes. Right? Yeah, so that's why you don't know what's going on.
Oh, no, I understand that, but I feel like if I seen it on the quiz, it'd be a little confusing.
Yeah, why so?
I don't know, it's a lot of stuff to do. Stuff to
Because when you take a quiz, you forget everything.
Sure. So, okay.
Yeah,
I see what you're saying. That's fair. How do you feel now?
a little better.
Yeah. Eads? How do you feel now? Like, I know quiz is a different story, but like, how do you feel now about this stuff?
Feel good.
Yeah. Parallel if they're the same, right? Drawing them. Do what they say. I'll do one more example. -1, -2. Start it somewhere. I'll start it here. -1 means left 1. -2 means down 2. So that's this vector. I bet you can tell by looking at them, they're not parallel, right? But I know they're not because, look, they don't equal each other. How do you feel about writing that? Let's call it vector M for McCartney.
What about the other one?
You guys can worry about that one. Let's find the magnitude of the orange vector. Orange vector's components are -1 and -2. So we square and root them to find the distance, right? -1 squared is 1. -2 squared is 4. So root 5 is how long that is. It's not a very big one, right? How you feel? If you want to, you can write this stuff down or not. It's up to you. Everything's made up. The points don't matter when it comes to homework. I want you to learn. So if you want to write this down so you can look at it later, great. Give you a couple seconds to do so. Finding the magnitude is p-fag. Square them, add them, and root them. It's the length, right? Distance formula. Make sure you do that for that last vector, 4, 8. Find their magnitudes. Is the orange vector going to be parallel to the light blue vector, 4, 8? It will, right? Because -1 over -2 is a half, right? 4 over 8 is also a half. So they're going to be parallel. They're going to be running in the same direction. Again, you can put the vectors anywhere you want. Ivy, tell me when you're ready, okay? Cool. Next page, it says translate by a vector. Translate means to slide it. Vectors are movement. So we're going to move all of these points for this triangle by 5, 9. That means 5 to the right and 9 up. So move everything 5 to the right and 9 up. That's all it's saying. So here's what we're going to do. Let's pick point A, move it 5 to the right, and 9 up. So 5 to the right and 9 up is here. That's new A. A prime is what we call that. And we moved it by this vector, this guy. We're going to do that for every single point. C, 5 to the right, and 9 up. Right here. C prime. Cool. Now let's do it for B. 5 to the right, and 9 up. B prime. Oh wait, hold on. 1, 2, 3, 4, 5, 6, 7, and then 2. Yep, we're good. I moved it 9 up. So the same vector to all 3 of those. They're all the same vector. And then we connect our lines to move our triangle. Same triangle, just moved by that vector. It was translated. Translate means to slide. How do you feel about that? What we did is we took the original coordinates, some xy coordinate, right, for A, and we moved them by adding 5 to the x and 9 to the y. Right? We moved everything to the right 5, so that's plus 5 in the x direction. We move everything up 9, so that's plus 9 in the y direction. That's all we did. How do you feel? These? So here, they said, do this vector and find the new image, right? Here they said, look, I already have the new image. What vector did I use? So we're trying to find out what vector they used to get from one triangle to the next. Corinne. You what? Yes, you do, because we did it before in class. Also, because you know what's going on, because you answered this question last time that I'm going to ask next. Yes. How do I know where I start and where I end up? Which direction are we going? Are we going from here to here or here to here? Exactly, right? We're going that way. Prime means new. So those are the vectors that we're using. Notice they're all the same vector. They're just copy and pasted. Now we need to know what their components are. How far to the right, how far to the up, right? Yes. Okay. What is it? So the way he did that is he said, look, I'm starting on A. That means I went 5 to the right, or 5 to the left, I should say, so that's negative, right? And I went 3 up. Cool? You'll notice that every vector is the same vector. They're all negative 5, positive 3. Because when we slide something, it moves it by the same vector. Everything gets moved in one direction. Insert one direction joke. How you feel? Fine? Last page has definitions that you need to do. That's in the notes. You have notes up on Google Classroom if you didn't get the handout from me earlier. The ones on Google Class are in color. Fill out the definitions. Then it says draw a vector, label it, find the magnitude, and label the horizontal and vertical components. Here's what you need to do. Down here, don't put that away. You need to draw a vector on here. You can start it anywhere. Draw any vector you want. Make up your own. Then I want you to tell me its components, right? The pointy bracket things. I want you to find the magnitude as well. And call it something. So mine might be vector D for Derek. I don't know.
So we're supposed to like draw the lines that we did on the first page.
Yeah, draw a vector. Any vector you want. Tell me what its horizontal and vertical components are. These guys.
Make up our own points.
Yeah. Just make up your own vector. I'll come around and see how you're doing. So draw your own vector. Yeah. Yeah. Nice.
I got a question, man.
Yeah.
So there's a point.
Okay, starting there. Awesome.
So then we go 3, 4 from that.
Yeah.
So
If that's what you want to do. Now, remember, this one's the horizontal part. And then that's vertical. So 3 to the right is what that says.
Oh,
So, nope, you can start wherever you want. Okay? So pick a random spot.
1, 2, 3.
Ah, okay, so here's the deal. This isn't a coordinate. A coordinate would be written like this. Right?
Oh,
These guys have 20 brackets, so this is a 3, 4. That's not what we're doing. Now, you can start it wherever you want. So let's just pick a random point that isn't that so you don't get confused. Right, let's pick that point randomly. Okay? Now we're going to do this to it. Your vector is 3 to the right. 1, 2, 3, 4 up. 1, 2, 3, 4. So that's your vector that you drew. Now you can put that vector anywhere. You can draw it again here, here, here. You can even draw it from there, right? But this tells you where you're going. It's pointing brackets, okay? Where you choose to start is random. Doesn't matter.
And then we just keep doing 3, 4 from that.
Nope. That's just all it is. It's just 3, 4 once, okay? And that's the vector. It goes from there to there. So if you were to take this vector and apply it to something like we did back here. Here's your vector. It's 5, 9. So here's a 5, 9 vector. If I put it on A, it shifts A over here. If I put it on B, it shifts B over there. If I put it on C, it shifts it there, right? So we can put our vector wherever we want to shift things. So you chose this point, and you shifted it over there. That's all it's happening. Okay. Now we need to find the magnitude. How far did it move? And that's going to be feedback. Does that make sense? Okay. Feedback. McCartney. All right, so you made a vector. First of all, use pointing brackets.
That's x plus y, right?
A squared plus b squared equals c squared type deal. Not this.
Okay.
We found the magnitude for this guy in red. So I took its component 6, 4, right? It's 6, 4. And that's what we did. A squared plus b squared equals c squared, right?
Okay, so mine would be
This guy, 3, 4, right?
3 squared plus 4 squared.
And then we root c, right? So we root everything. Right, there you go. Add them up first. Yeah.
I usually use for A and B.
For the magnitude, yeah. Equals c. I'll show you a graph in a second. Degeneration. Again, you take that, put it anywhere you want. Do the same thing. Amazing. Vector M, first of all, only one arrow right down to two. Otherwise, it's raising one for every vector. It's not. Why vector M? Alright. Okay, I got creative. Alright. So this guy, first part, is actually going to be your horizontal. So you're going to move left. And you went down. You need a better eraser. Not that you use it. Here if you want it.
Matt, how are you doing?
Okay. Yes. So there's your A and your B.
What is going to come out to very,
A nice number? That's fine. Most times it won't. Add them up and root, right? That's length. Sometimes lengths are weird. Alright, now I get to do graphics thing. Pick a point, randomly. Pick another one. Okay, now you're going to do 5 through you. So 5 is right. Yep. Try to be on doctor.
I get
25, right, and actually comes out to a nice number, but I would accept that as an answer. The root of 25 is actually 5.
Oh.
But even if you didn't write it, that'd be okay. Most of the time you are going to get a number that you can't do anything with. But yeah, that's the magnitude. And there's your vector, 3, 4. Bad.
This should be better.
how do you do this?
Look at the components.
Matt, it was 34 squared. Right.
This is 2. So, bunch of 4. 5, 4, and Fair enough. Most people use letters, but vector 12. Wow, it's the same thing. Oh, but you remember the root. Okay. Right there. How about you? Feeling good? Feeling great? 5, 6. Excellent. Anybody else name their vector 12?
What do I do?
To
What do now?
right the whole vector. Yeah. 5, 8. Is that how you are? Nice.
We only need to do one vector.
Yeah, how many did you do? I think 3. What did you do?
I got 5.8.
5.8? Awesome. You don't need to use a calculator. So you just use that extra word. Congratulations. 34 is this is good around. This is around twice.
So where's the third point?
I'm going to do 3rd point. You want from here? Actually, you use that a little bit. So grab your vector. You use your range point. And you do 5. You do 5 right. Vector M. We have 2 vector M's. M for McCartney.
That's all you gotta do?
That's all you gotta do.
Did the magnitude?
You did? No. What did you change it to? An A for what? Got it.
I got a question. The magnitude is the A squared plus B squared?
Now root 9. 25 and 4 makes it 29. So make sure it's root 29. Other than that, vector A. Vector A, yeah, at least your vector call. Think for yourself, okay? Great, you bought it.
Left side.
Of the perfect man.
Lick it. Delicious. I'll take 12.
Oh, he's fine, so I just had
Little snacks just like popping in the mouth. That's how you gotta sell them, right? You gotta figure out what they want. Ivy, don't tell them they're candles, okay? What you do is you figure out what they need. Kids hungry? Tell them it's food, right? Kid needs some chilled gas, that's what you tell them with that, right? You find out what they need, and then you sell it based on that. That's the smart sell. Exactly. See? You're not buying candles.
Why do I have 2 erasers? What can I mistake?
Which one is?
No. 1. All right. That's translations, guys. That's it. Sliding stuff by vectors. That's as hard as it gets. Now we've got this, where things are going to get weird. I don't like your attitude.
Right. Like the attitude to the left. A little off. It's because Maddie's gone.
That's right. We don't have the yin and the yang to balance.
Signing in the icon.
We might have already done this in class. But I like it.
Just homework for Hank?
Something like that. That's cool. And we have so many rules in here, and one of them is never pass stuff back.
Isn't today 12?
Yes.
All day.
I miss when Disney Channel was every day like.
Don't we all? Cody Simpson, where are you?
Yes, Dave.
I do, back there. This one doesn't work. It's just a paperweight. Somebody broke it. All
All right. Here's what we're gonna do.
I like this one. Pomegranate.
Did we use these before or did we not? I didn't think so. So here's the lesson, kids, because I have to apparently do this. These bags are Ziploc, which means you can open them up and seal them later if you don't rip them open. Other kids are like, think of McDonald's toy. Like, come on. Yeah. Okay. I don't know. I'm a man. Okay. So here they are. Open them here. Don't just rip into them. Here you go. These things don't grow very well, so they're probably gonna flutter. Just cuidado, por favor. Got these from my mom. She's a guidance counselor, and they gave these to her for park testing or something. And just like me, she hates testing, so she stole these from park and gave them to me. Yeah, see, look, this is last year. Freaking dummies.
No.
Ooh. Oh, got him. He's only got one joke, but it's a good one. It's a good one. All right. But can you find your ideal man? What is it's called? The perfect man? Can't find your perfect man at Walmart. Exactly.
How much are they? $14 for this.
I didn't know that. I was not informed.
That checks out. That checks out. He didn't know.
Are you an FFA?
Let me smell that one.
It's Sunday.
Oh, give it to me. Give it to me. Well, I don't need a candle to do that, though. I make it myself. Dang.
This one smells like that.
That's good.
Oh.
All right. Here.
No. Don't give it back.
All right. So here we go. We're going to graph this line of reflection, and then we're going to reflect the image over it. So how do we graph a line like this? Well, it's in slope-intercept form. So that's our slope. Corinne, never change. Corinne is a hater. But that's all right. That's why I like her. Can't take it back now. Can't take it back now. So this line has a y-intercept at -2. So here it is at -2.
-3, -2, is that what you said?
-2 is the y-intercept. So down here too. Now -3 is the slope, meaning down 3 over 1, right? So from that point, we're going to go down 3, right 1. I'm going to keep doing that because we're making a line. I'm going to make my line as accurate as possible.
Wait, what do you do?
Well, Ms. McCartney, nice of you to join us. -2 is the y-intercept, and then we do the slope down 3 over 1. Smell what I'm stepping in? I know, because you had candles. That is what you were smelling. You weren't smelling what I'm smelling.
Dude, I swear.
By the moon and the stars in the sky. Right? All right.
I thought about it.
Thank you. So here's our line of reflection. Here's what we're going to do. After you have that line graphed. Do you have that line graphed? Ava, you have that line graphed? Yes? How about Isabel? Ava, take care of that. I put you over there for a reason.
I'm taking the ring protractor.
Don't do it, and that's not a protractor.
Oh, yeah?
McCartney, don't do it. I don't want her to hurt me. McCartney! You think it's all fun and games, but then you leave, and then Corinne takes out freaking ruler and starts beating me with it. Okay? All right.
What?
Yikes. Yikes. Like, we were on the border there, and then you just pushed it way too far. Maddie, enough. All right, so here's what we're doing. Here's how this works. If you look through the side where the image already is, you'll see a reflection here of the triangle. Yeah, it's like a mirror that you can see through. So look through the right side, and you'll see the reflection of the triangle. Now, I'm right-handed, not left-handed, so I'm going to flip the paper. That way I can write that or draw that triangle.
Oh my God, I see it.
Check it out. Yeah, you can see the reflection a little bit. I'm going to take my pen, and as long as this is on the line of reflection, and I'm going to be as careful as I can, when I trace this, what I see, right, I'm going to get the perfect reflection on the other side. And there's my triangle.
It works.
It does, doesn't it?
Well, I mean, I don't understand.
There it is.
Right, like it does not work.
So here's what I did. I turned the paper because I'm right-handed, so that the image was on my left side. I put my protractor on my line of, or not my protractor, my reflection tool on the line of reflection. And then I drew what I saw.
Oh my God, I did it. That works.
Was your line of reflection different than mine, Maddie? Is that what happened?
Look at it.
That's good. Is your line the same as mine, Maddie? Does it go at -2 and then down 3/1? Okay. That's right. You got a shoe game. How do we feel? Doc? Awesome. Ava, she figured it out yet or no? Next one. Now things are going to get weird. All right, so line of reflection, let's graph it. What's the y-intercept for this line? 1. So +1 is where we intersect the y-axis. What is our slope? Up 1 over 2. So your line should look like this. Wow. 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 Corinne, are you sniffing the candles?
Yeah, it smells like vinegar, and this one smells like a car wash.
Wow. Vinegar and a car wash. Corinne, I think you'd be a great salesman. We got car wash and we got vinegar. So that's line of reflection. That's where your reflection tool is going to go. This one's going to get bizarre. So turn the paper and be ready to draw what you see.
What the? This don't make no sense. It does a little bit. What side do you want it on?
Well, we're going to draw both of them. No, turn the paper, you dingus. Then turn it to where you don't have to do that. So I drew this part.
Oh my.
Now I'm going to draw the other part.
This is some next level stuff.
I know.
Do we all get the sampling thing? I don't think I would carry around the samples though.
What?
Oh, I sell eggs.
This one is hard. Well, my second one wasn't as good as my first.
How
This one's a hard one.
Okay, that's not too bad.
Yike.
What flavor do you have?
Thank you, Corinne.
Do you have them with you?
All right, this is happening.
It smells like meats. It smells like a car wash.
Oh, that's
You know, like the berry flavor.
So the car wash uses berry flavor. So it smells like berries, and this smells like a car wash. So this smells like berries. Is what you're telling me.
It smells like a car wash.
Which smells like berries.
I think I have faith.
You're like, this smells like a car wash. It smells like berries. From now on, when I smell anything, I'm gonna go. This smells like a car wash. That smells like,
Do you have like a?
and that's how I'm gonna get it by. Pancakes in the morning. This smells like a car wash. That smells like pancakes.
So you get 16 different flavors, right?
dude, this does not make sense.
Well, maybe I want two.
Well, then you buy two.
Eads, what I have is
Oh, I hate
-1, 6.
Oh, chill out.
I've got
When are they gonna be here?
2, 4. 1, 2, 3.
It's like a month away.
5 minus 1. 4 minus 4. And -4, 2 is what I got. If I'm reading this correctly. Yeah, it's -1 count of 6, sorry. Yeah, I understand that. Those are the points I got. I'm not grading it, so don't worry about it. Write it down anyway, I suppose. Yep. Students are dumb. I'm not grading this. Stop writing it down. Stop. It was for fun. It was for fun. The only thing you learn in school is how to copy stuff down. That's all you ever learn.
Maddie, send me the link. I don't know how to operate Facebook though.
Tomorrow, we're going to do some more reflections.
Corinne, do you want your
You're going to throw it? Go for it. Put it back in the case.
So this doesn't have to do it?
It is.
Hold up. Just threw it.
What did you say?
Watch this. Video
Phenomenal throw, McCartney.
There you go.
Join basketball.
Oh, you. I knew it was going to hit you. That's why I didn't say anything.
My eraser.
My eraser.
What happened there?
All around me are familiar
Maddie, you
faces.
said $20.
20 bucks. Shut up, Brando.